Bismillah, alhamdulillah, salatu wassalamu ala rasulillah, assalamu alaikum wa rahmatullahi wa barakatuh. In this session, we're going to use the data that is in Blackboard titled Cost Behavior Data, and we're going to use regression analysis to analyze the cost behavior. Now, let's try to understand the situation. What we have here in our data is four elements: the beginning of the production week, the amount of production in units, and then we have the column that says busy. It's is this production in the busy season or not in the busy season? And then column D is the total production cost. Now, the company produces boards that are used to make decks, and this data is from a country where there is not a lot of use of the wood to make outside structures outside the home, decks and such during winter. So their busy season is from January until the beginning of June, and their slow season, not so busy season, is from June, beginning of June, first week of June until the end of the year. What we want to do is we are given the total production cost and we are given the units of production, and we want to see in the production cost through regression analysis how much of this production cost explains the production, meaning if we take the production as independent variable, is it affected by the production cost? I said it backwards. The production cost is the independent variable, the production is the dependent variable. So we want to see, first of all, is the production dependent on the production cost, and then through regression analysis can we figure out the amount of fixed cost in the production cost and the amount of variable cost. And we discussed the fixed cost is something that is fixed regardless of the number of units produced, and the variable cost varies with the number of units produced. So let's first put some data into the busy column, and we are going to put 1 for the busy season and 0 for the non-busy season. And you see here on the right side there is a formula here that you can use. Instead of going into each box and putting 1 or 0, we can copy this formula. This formula is saying that we have to copy the formula without the star at the beginning. I put the star there so that the formula is visible to you. So we're going to copy this and we're going to put it here in the busy column C2, and you see it calculates 1. That means this is in the busy season. So let's try to understand the formula. The formula is if A2, which is the date, value is June 5th or later, then it's a non-busy season. And if it is June 4th or earlier, then it's a busy season. So for the busy season, the Excel will put a 1, and the non-busy season, Excel will put a 0. So you copy that formula, and we will copy that down to all the way to the bottom of the sheet. We only have 53 observations, so it's easy to do. So we paste it, and now you see we have 1 for the busy seasons and we have 0 for the non-busy weeks. Okay. Now we have done regression in an exercise in chapter 7. So the way we do this is we're going to do 2 regressions. So the first, we want to find out, does the production cost explain the production? In other words, do we have more or less production when the production cost is more or less? So that's the first question. And also we want to know how much of this production cost is fixed and how much of the production cost is variable. And from the regression results, we will see how we can answer those questions. So we go to data and we go to data analysis. Okay, so data on the top and then data analysis, and we select, come down, we select regression. Okay, and then we click OK. For the input range Y, we are going to put D1 to D53. So this is our independent variable. We copy all the way down. And then for the dependent, we have the production B1 to B53. Okay, and then we're going to click this labels and we leave everything alone and we click OK. All right, now we have the results. Let's label this results 1. Okay, now if you remember from our previous regression, first we're going to look at the significance of the F statistics. Let's format this to read it in an easier way. Let's change it into numbers and 4 digits. Now this is a significant number because this tells us that the probability that the production cost is, the production units is not explained by any variable is practically 0. So the significant F stat indicates that there is almost 0 probability that production cost or production is independent of any other variable. Okay, so that's our first statistic that we look at. Okay, let's save this file as cost behavior solution. Okay, now the second thing we look at is the R square. Now the R square explains our model, and if it is 0, then the model does not explain the relationship, and if it is 1, then the model perfectly explains the relationship. And we can see that it is 0.86, which is 86%, which is pretty good. So our model that we're trying to predict the production based on the production cost, it's pretty solid. Okay. The third thing we look at is the t statistics and the p-value of the t statistics. So let's try to convert the p-value into a number that has 4 digits after the decimal point. So it's 0.0000. Now, as you know, if the t stat is 2 or higher with a significant p-value, then the production cost explains the amount of production. Okay, so what we have here is that we're trying to predict the production based on the production cost, and if the t statistics here is 2 or higher with a significant p-value, which is here we have 0.0000, meaning there is almost zero possibility that the production cost does not explain the production, and it does. Okay, now in addition to this, we have the question that how much of this cost is fixed and how much of this cost is variable. So if we come to the intercept is the constant, which here it shows us the fixed cost, which is $6,185.38. So what is this? This is the constant, meaning for every variable of production and production cost, this is how much cost is the minimum that every single production has as a fixed cost. And then here, this variable production, the coefficient, this tells us what the variable cost is, and the variable cost is 51 cents. So it's 0.51, right? So this is 51 cents, and this explains to us that the cost in every level of production is made up of fixed cost of $6,185.38, and for every unit it is 51 cents. Okay, so this is our first regression. The second regression is we want to know if there is an extra cost in the busy season, or if there is a difference between the cost in the busy season compared to the non-busy season. And we are going to do another regression. Here we go to the same place, data analysis regression. The input range, which is the production cost, we keep that constant. The production, here we are going to do B1 to C53. So we are going to include in our calculation the season, and we leave the labels and then everything else alone, and we click OK. All right. Now here we label it results 2. Now again, we start from the F statistics, and without typing it in here again, we see that it is significant. That means the production is explained by our independent variables. Our adjusted R square is also a good number, which means our model is solid. And then our T statistics here, it is 2, and the p value is also 0.03, which means at 0.05 it is significant. That means our variables are explaining, our independent variables are explaining the dependent variable. Now what extra we want to look at here is this variable which we added to see if the busy season has any effect on the cost. And indeed we find extra cost during busy season is $4,858.67. So here again, this is the extra. So we find that it costs the company an extra $4,858 during the busy season for production. So the second regression adds this extra knowledge to us. All right, so this is the end of our analysis.